Hi, everyone. Uh, Again, I'm Scott. This is drone.Follow, but that is subject to change, and I will tell you why in a bit. All right, so again, description is maintained as follows. It's a build a drone, primarily design the flight control software using IMU. The product would use the one from Xheli. I'm obviously using a different one, as I've mentioned, but in a nutshell, that's what this project is. All right, so there's been a lot of progress since last presentation and since last milestone. The first of which was in data manipulation. So I was able to use a low pass filter for the accelerometer data using a low pass filter because the accelerometer data is highly susceptible to noise. So using this filter kind of levels out that noise. I take the integral of the gyroscopic data because that is degrees per second. That's the data I get it in. So I convert that to the integral of that is just degrees, and then I convert that to radians. And then I use sensor fusion. So basically half of the data is gyro, half is Excel, are the accelerometer values, and that's so far proven to work. Flight control, I used a PID controller, low proportional gain so that the steady state error wasn't too crazy, high derivative gain to drive the error down quickly, and then integral gain is a tenth of what the derivative gain is, which basically just levels out the steady state error as well. So I haven't achieved proper flight control, unfortunately, yet. But what I have done is I've created an equation to relate thrust to motor RPM, and I did this through testing. So I commanded the motors to go to varying degrees of RPM, and once it started to generate a lift, that I assumed to be a constant, and the constant in this equation, which I could have put down here, but I didn't, is thrust equals K times omega squared, where thrust is in newtons, omega squared, or omega is in radians per second, and that K value takes a lot of math and such and boils it down to one constant. But basically that K value takes into account the fluid dynamics of air on top of the rotor and underneath the rotor, takes into account the weight of the chassis, the geometry of the propeller blades, the nominal lift diameter, and so much more that just is boiled down to that simple constant, which I just got through testing. So once it generated lift, I was able to like reverse the equation because I could relate the motor speeds I commanded to the force needed to generate lift for this drone, which is just its mass. So it's the force is F equals ma, so it's mass and acceleration to gravity. I was able to kind of do the math to find the proper K constant. But after that, I've had trouble mapping the Euler angles from the the data manipulation to motor speeds, and that's a very important part of this. So that's knowing like on what tilt do I command the motor to go to these speeds, you know? All right. So I figured I might as well show you the drone at least flying. So because I've created a website, and let's just at least show you the website. So hopefully you can see we're gonna X out of this presentation. This is the website, drone.Follow, made it a little nicer. Basically, individual commands to increase and decrease each of the motors, kill motor commands, a little log displaying. I just found out I can actually type in this, which is cool. So maybe I can do that to send commands further in the future. But yeah, just simple GUI display. I have it up on my tablet and I'm connected to my drone's Wi-Fi. And I will just switch around some. I got my phone that I'm gonna, yeah, all right. So we're going to stop the share and then turn on this. We're going to, this is kind of a lot. All right, can I flip the video? Sorry. Evening settings. Let's pin this. So that should work. And we're gonna start video. I think we're just gonna go like that. Yeah, we're just gonna do that front camera. All right, drone. You can see it. Yeah. Basically, the entire weight of this is 731.5 grams minus the breadboard. Not super crazy. Just for reference, website, base RPM values right here. Obviously, you can't see it very well, but I'm just going to individually command the drones, the motors, just to show that I can do it. This is dealing with motor 1. You can see there's this kind of like has to achieve that like stall RPM. Basically, I'm increasing it by on the order of 5 RPM. So that was 1150 revolutions per minute that got it to really go. So turn that back down. And you can see that it's different levels. So right now we're at 1090. So that's motor 3. Increasing motor 3. 1165, decreasing motor 3, killing the motors. Then motor 2, decreasing. Then motor 4. Motor 4 was a lot easier. So basically, it ranges from like 1130 to 1190 on what those like starting RPMs are. And I found that it was about 1525 that RPMs for all of them that generated lift. Unpin the video, remove pin, and start share, and go back to the presentation. So yeah, that was, we're gonna make sure that this is completely off. All right, that's off, just have to do that, and I'll power that down after the presentation. But yeah, so that was my ability to control it. So in future considerations, seeing as my last milestone for the goal for that was to have stable flight hovering, that didn't happen. So that's now pushed to milestone 5. As a result of this, my end goal is likely not to move forward, right, left, and back, but rather I was thinking about having the drone rotate in a full 360-degree movement while it maintains a stable height. I think this could have a couple results. Like maybe I can mount a camera and take a 360-degree picture and things like that. Or alternatively, I can maintain the drone.Follow type concept and maybe have its orientation follow that. I don't know how well I'll be able to do that, seeing as the yaw heading control is the harder angle to control in flight control because I don't have a magnometer. But yeah, milestone 5 hovering. Yeah. So I'd hoped to interview Professor Rubenstein by the time of this presentation, but he has not gotten back to me. But the questions I was going to ask him is these resources for resources in his 2 cents on mapping angles to motor speed. So understanding that relation so that I can get this controller up and running. And again, also ask him if my sensor manipulation and data manipulation was good. And to just basically have him validate that. And if it's trash, have him provide suggestions. So with that, not incredible amount of questions. I talked with Professor Mickelson, and he said he may have some resources for ESP32 PCB design. But if any of you have found something, that'd be greatly appreciated, because I am looking to design a PCB for this. And then finally, any improvements to my website. Right now, I have it very simple, obviously, and I think it would be cool to expand this out and make this a little bit more robust or user-friendly or have a higher aesthetic. So thank you for watching. And I look forward to seeing all of your presentations.